Hello, everyone. Welcome back to SAT Math Question of the Day. Here's our question. Please read it, pause it, and we'll try it. Okay, someone is hosting an event for 100 of her fans. For the event, she meets each of her fans one at a time at a constant rate. Okay. After 90 minutes, she's met 45% of her fans at the event. Which of the following equations models the number of fans F remaining after Takata? Remaining for Takata to meet M minutes after the event has started. Okay. Well, it doesn't seem like an exponential problem.
Well, it's not a matter. It doesn't seem. It is not
Okay.
an exponential problem because they tell you that she meets each of her fans one at a time at a constant rate.
Yeah, right. Yeah.
So rather than say it seems like it's not exponential, the first line in the problem tells you that it is a linear. It has linear behavior.
Right.
And so you could rule out the exponentials immediately.
Yeah. To beat M minutes. I see. She has 100 fans. So the question is, do you do minus after 90 minutes she's met 45% of her fans. Which of the following models the number of fans remaining for her? Wait, but this is the only one that makes sense, because if this was, why didn't they make this 0.55? It would have been a better distractor, wouldn't it? Just by looking at the number, she's met 45% of her fans. Yeah, so in other words, this is how many fans she's met, so how many she has left is 100 minus that. Which is, I don't like the way Seth's looking at me. Which is like models number of fans. I'm wrong? After 90 minutes, she's met... I'm scared about this problem. After 90 minutes, she's met 45%.
There's several steps, Yeah, it's a bit confusing. So I would say, we have to be careful about the percentage of fans that she has met, and the percentage of fans that remain to be met.
Wait a second. I think the answer is exponent. The answer may be C or D. Wait. I am totally blown by this. But I must admit, I woke up late.
No, the first line tells you it's linear.
Yeah, the first line's telling you it's linear. After 90 minutes...
But the issue is, the situation is after... So M is the number of minutes after the event begins. And so the choice is the two formulas here. Now, F is supposed to represent which of the following models the number of fans remaining.
Yeah.
Well, initially there are 100 fans.
Right.
The feasible formulas give you the number of fans remaining. And so what is subtracted should be the number of fans already met.
That's right.
Now, since the original number is 100,
right,
these numbers of fans is identical to the percentage of the fans.
Yeah.
Okay. So the thing is, so they tell you after 90 minutes, she met with 45% of her fans.
Right.
right? So we apply this situation. So we have minus, no, sorry, we have, point X, the unknown, right? Times 90 minutes should be 45, right?
Okay.
So we need to pick among half and 45 hundredths, which one gives you the fraction times 90 equals 45, and it's immediate to see that the fraction is a half.
Yeah.
So the answer is this one.
Wow. This is a really tricky problem.
Yeah.
I'm not sure.
It's because they tell you the data is the number of fans that she met, but F is the number of fans remaining. And the formulas for F are in terms of the original number and the number that she met. So you could cancel, cut out the middleman and simply solve the problem in terms of the number of fans that she met after the first 90 minutes, which I tell you.
After 90 minutes, I still just
again. I wrote these two linear terms.
Right.
Are the number of fans already met after m minutes. Okay, that is the circled figures. The F's are the number of fans remaining. Okay.
Right.
And of course, we know that these linear terms are negative of the number of fans already met because they tell you that the original number is 100.
Right, of course.
So the original number is 100. You know the original number is 100. Okay. We are told that F is the number remaining. And so the original number minus the number that she met is the number remaining. Right? The original number minus the number that she met.
Yeah.
That means the number remaining.
So I first have to say two things. One, I woke up very late today. We filmed this at around noon. And I haven't had anything to eat at all today. So I am hungry and I cannot concentrate that well.
So what's your advice for taking the SAT?
Absolutely have a good breakfast, because if you don't have a good breakfast, you will do what I'm doing, which is I still don't know how to do this problem. So whatever you do, eat well and make sure there's a nice amount of blood sugar and nutrients in you before you take this test. Otherwise, you're going to end up like me, where I still can't do the problem. Okay, that's one thing. And also bring snacks. I think they allow you to eat in between the test sections. Bring breakfast bars, bring things, okay? Keep yourself well fed. The other thing is, maybe to help me do it is maybe I will just put in 90 minutes. Maybe I'll do the problem with 90 minutes and see which one is right. So let me try that. Maybe this will work better for me. So 90 minutes after the event, she's met 45% of her fans, which means when I'll do F of 90, we know F of 90 must equal 45, right? We know that, right? Oh, no. F of 90 is 55.
F is the number remaining.
I caught myself. I would have caught myself.
Yeah.
F of 90 is 55. Absolutely. We all agree, right? Because F is a number 90 minutes after the event, she's met 45% of her fans, so that means she has 55 left over. So we know F of 90. If you put 90 into these equations, you better get 55. So, which is the only one where, now if you put 90 in here, and you put 90 in here, you can use a calculator. Half of 90 is 45. So 100 minus 45 is indeed 55. Seth is correct. So, although I may not really quite understand how to derive that right now because I have no sugar on my body, I have no nutrients, at least the other way to do this is to test which one. But I was really deceived by this. I just used my intuition. And boy, intuition is not good, particularly when you don't have any food in you. So, just to be safe, then not a bad idea in this problem is to actually, because this is Seth, you must admit this is a tricky question. This is not the easiest question we've had. This is a tricky question. So maybe in tricky questions you don't want to be complacent and you want to test your answer.
Well, they added two relationships that cancel each other out.
Yeah. I must admit, Seth, you're pretty smart getting this. And yeah,
well, this problem, some of the SAT problems, like not all of them, some of them are very straightforward.
Yes.
Others combine facts which have to be, some of the, like this one gives several relationships.
Yeah.
And you have to compose the relationships.
Yeah.
So some of them give you a direct relationship from which you could solve for the unknown. Here they give you two relationships, and then when they compose, basically the data, after you compose the two relationships, then you get one relationship that tells you immediately what the answer is.
Yeah.
So it's so this is the kind of thing where you have to think carefully, and you have to think carefully. Thinking carefully it means that you extract from your reading the precise meaning of what the writing says.
Right.
As opposed to getting an impression.
Yeah.
Because often the SAT questions are simple enough so that your first impression is a correct interpretation of what you're reading. But this is complicated so that the impression you get, for both of us, for the impression that we first got was not a direct, accurate interpretation of the meaning.
Yeah.
And so beware of telling when you have to, of course, how do you know whether your impression is accurate, or whether you have to carefully parse the words.
But in the end, the thing to be alerted here is percent questions are tricky. I find percent questions have always been tricky ever since I learned percents in 5th or 6th grade. So that's an alert that one wants to be a little less you don't want to be complacent. The other thing that's very unusual about this problem, and it's really, really, maybe that's why the intuition fails, is the unit analysis is weird. It's weird because 100 is the unit of F is fans. 100 is fans. But the
Yes.
unit of M is minutes, and percents don't have a unit. Not necessarily. They do actually here. They do. So, but
M is minutes.
M is minutes, but F is in fans. But the 45 seems like a percent. And just intuitively, right? So you would multiply a percent, and does it have units by minutes to get minutes, which is not the same.
So the thing is, I think what's happening is if instead of 100, they gave you a variable like t. Suppose they gave you t instead of 100. Then 45% of the fans at the event would be 45% of the fans at the event. The number that she met would be 45 100ths of t. And in this case, 100 would be t, and this 0.5 what would the 0.5? The 0.5 would be in terms of t.
Okay, are the units of 0.5 fans per minute? Because that would make it work. Are the units of 0.5 fans per minute? Because then they'll
yes, obviously, yes.
Aha.
But it's also because there are 100 fans.
Right.
Because there are 100 fans,
right.
The units of 0.5 are both fans per minute and percentage of fans per minute.
Right. No, but for the units to work out, this has to be the 0.5. The units of 0.5 have to be fans per minute. Otherwise, the units don't work out because we agree F is not.
0.5. But because the number of fans is 100, the percentage of fans is equal to the number of fans in each of these occurrences.
So how do we derive there are 0.5 fans per minute? So that means after 90 minutes, she's met ice. Well, okay, after
90 minutes, she met 45 fans.
Fine. So after 90 minutes.
But 45 fans is 45% of 100.
So after 90 minutes, she's met. Oh, right. After 90 minutes, she's met 45 fans. That's where you get the half.
Yes.
That's where you get the half. Notice unit analysis comes through again. Comes through again. Unit analysis, we keep saying it.
It's a bit tricky with the unit analysis. It's unusual.
No,
it's a very special case because they gave the number of fans as 100. And so numbers of fans and percentage of fans are the same, have the same values.
If I do it the way I just did it, where I just do the problem and not worrying about percent. I don't even worry about percent.
You have to worry about percent because the data, the statement of the data says 45% of the fans were met.
Seth, let me finish talking. If you look at it from this point of view and you look at the analysis of the units, you realize that the unit of these numbers has to be fans per minute. So then you ask yourself, how many fans did she meet per minute? They give you information. 90 minutes, 45% of her fans, 45% of 100 is 45.
Yes.
So the answer is 40. The answer to the units, the answer to this factor is 45 over 90, which is a half.
Yeah.
You essentially did it here.
Yeah.
You essentially did it here, right? But I must say the unit analysis really keeps you honest, like I always say. Unit analysis keeps you honest with these problems.
Yeah.
Yeah.
Well, I like your remark that you could, everything in the problem is in terms of numbers of fans, except for the data that says after 90 minutes she met 45%.
Yeah.
So it makes sense. And I think it's a wise first step is to eliminate the percentage.
Yeah.
Figure out how many fans is 45%. With then now you could they give you the data to figure out how many is 45% from. They give you that the total was 100. So you calculate 100. 45% of 100 equals 45.
Yeah, I know.
So we could eliminate the percentage specification.
That's right. Exactly.
And say that after 90 minutes she met 45 fans.
Right. Exactly. That's right.
Okay.
Yeah. And then you go from
there. So how many fans are remaining? Well, that's 100
minus
45. And so we match what either 0.5 or 0.45 gives you 45 when m equals 90.
Yeah, that's what I just did. That's what I when once I admitted that I had no nutrition in me, that's the way I looked at it. So wow, this problem is pretty rich. Now also it's a notice I totally blew it. You learn a lot when you blow things. You learn a lot when you make mistakes. But really the most important thing is eat a really good breakfast before you take the SAT or the ACT.
Yeah.
And bring snack bars with you and keep yourself well hydrated. They also give you a bathroom break. Okay. So I guess that's it. So wow, a lot here. So clear all drawings. We will try the answer. Let's see how they do it. I'd be interested to see how they do it. Let's see how they do it. Okay. Check how we answered the question. 4 steps, a lot of words. We need to determine whether
by the way, we have to remember, would this is there any benefit or for using a calculator?
Maybe
for this problem?
Maybe. I mean, if you want to divide what we had to do, whatever we did, 45 divided by 90, maybe.
Yeah.
Okay, here we go. What did they say for the answer, by the way? I just want to quickly look. The answer, Chaiken meets 45, so which means she meets an average of 45 over 90 fans per minute. Wow, that's how I did it at the very end. So the units,
right. So they start immediately. That's great. They immediately eliminate the 45.
Yeah.
They get 40. They eliminate 45% to get the number of fans, and
so
then
they've knocked out the confusing percent question. I'm just gonna leave that red thing. I hope people don't mind. If it's bothering, we'll clear it. We need to determine whether the scenario. Good. Thanks, Seth. Good. Okay. We need to determine whether the scenario is best modeled by a linear exponential. Okay. Dichotomy to constant rate. So it's linear. Okay, great. Now, so that's good. They did 2 steps. That's 90 minutes. She's met 45% of fans. 45% of 100 fans is 45 fans. This means she meets her fans at a constant rate of that. Okay, good. So they derive the rate first, which is a really smart way of doing it, which is also the way Seth did it. If you go back to what Seth wrote, he wrote there was a thing here where he did exactly that. Remember, he put a thing here where he figured that out. Yeah. Okay, since F, all right, so then you have to subtract that. Since F, the number of fans remaining decreases, the change is negative. Okay, negative 5. Of the show choices, A has the correct rate of change.
Yeah.
Right, correct rate of change. Slope, correct rate of change. So therefore, that's the answer. Okay, good.
So there's a lot of stuff.
Yeah.
There's a lot of stuff for this problem
a lot of stuff in this problem.
Is taught over years in school.
Yes. Yeah. Seriously,
the applications of subtraction.
Yeah.
And applications of multiplication.
Yeah.
together with fractions and percentages.
And linear equations.
Yeah.
And
Yeah.
linear decrease.
Yeah.
And slope.
Yeah.
And units. Yeah, there's a lot going
Yeah.
on in this problem.
Yeah. Yeah.
Yeah.
And
Okay.
algebra, we're using letters.
Yeah.
Letters to symbolize quantities. Yeah.
So bravo to them for making a problem that touches on a lot of stuff.
Yeah.
Okay.
I think I've back before the teachers told me about algebra. I thought, I thought it was really, really weird that you could multiply letters by numbers.
Yeah.
Okay,
everyone. I think we're done. Took us a while to do this, but that's okay. Remember, have some food before you take tests. I'm Joel. I have a PhD in mechanical engineering, if you can believe that, after not doing this question. My brother Seth has a PhD in mechanical. No, he has, no brain. PhD in math from MIT. Has been teaching at computer science at SUNY Albany for many years. He's now retired, and he has a really nice warm sweater. And and then we're here to hopefully show you how to approach different SAT questions, and also share the mistakes we make, like not eating. And our approach to studying for the Math SAT is go to Khan Academy. They offer hundreds and hundreds of questions sanctioned by the SAT people. So they basically tell you what you need to know for the test, types of questions you can expect on the test. Do as many of these as you can. There are about 600 to 700 math questions. Do them all. Maybe even make up a cheat sheet as you're doing them. Very good, particularly on the problems you're not sure about how to do. And then go to the SAT website and take as many practice tests as you can that are official SAT practice tests. And then you should be ready for the Math SAT. Okay, everyone, please like, dislike, give us comments on our video. We really appreciate the comments. And if you have any SAT math questions you'd like us to do here, please email them to us at satmathquestionoftheday@gmail.com, and we'd be more than happy to go through your specific question. Okay, everyone, have a great day, right? And stay warm, because it's cold out there, at least where we live. Okay, everyone, take care.